In graph 11.1, we illustrated two different production frontiers representing two different technologies. These production frontiers showed how total output on the vertical axis varies as the labor input on the horizontal axis varies. We'll now illustrate how to derive the concept of marginal product from these production frontiers. In panel A of graph 11.1, we illustrated a straight line production frontier along which each additional labor hour we hired always was able to produce exactly 4 additional packets of economist cards. Thus we would say that the marginal product of an hour of labor along this production frontier is always 4 packets of economist cards. The marginal product of an hour of labor is therefore simply the increase in overall output that happens because of the hiring of an additional hour of labor. And, as you can see from panel A of graph 11.1, that marginal product of labor is equal to the slope of the production frontier. Since the production frontier in graph 11.1a has the same slope everywhere, the marginal product of labor is constant as illustrated here. In panel B of graph 11.1, however, the production frontier did not have the same slope everywhere. It began with a relatively shallow slope, became steeper and steeper, and eventually again shallower and shallower. Because the slope isn't constant along that production frontier, the marginal product of labor is not constant, because the marginal product of an hour of labor in the graph is the slope of this production frontier. At the production plan A' in graph 11.1b, for instance, 10 labor hours can produce 10 packets of economist cards. Thus, on average, for the first 10 labor hours, the marginal product of labor was 1 packet of economist cards. We illustrate this here by indicating that the marginal product of an hour of labor for the 5th labor hour hired was approximately equal to 1. Going next to the production plan B' in graph 11.1b, we see that the next 10 worker hours increased total output from 10 units to 38, an increase of 28 units. Thus, the second 10 labor hours had a marginal product of labor per hour of approximately 2.8. We illustrate that here by showing a marginal product of labor of 2.8 for the 15th hour of labor hired. Next, the production frontier shows that when we go from 20 to 30 labor hours, our total output increases from 35 to 82, an increase of 44 packets of economist cards. Thus, the next 10 labor hours increased our total output by 44, or on average per hour by 4.4. We indicate this here by saying that the marginal product of labor for the 25th worker hour was approximately 4.4. Going from 30 to 40 worker hours, from production plan C' to H', we see overall output increasing from 82 to 138. Thus, these additional 10 worker hours result in an increase of overall output of 56 units, or about 5.6 per worker hour. We indicate this here as the marginal product of labor being 5.6 for the 35th hour of labor. Going from 40 to 50 hours of labor takes us from production plan H' to G' in graph 11.1b, and thus from output of 138 to 200. Thus, the marginal product of labor of these additional 10 worker hours is 62, or approximately 6.2 per worker hour. We get the same 62 unit increase in output for the next 10 worker hours that we hire, and thus again a marginal product of labor per hour of approximately 6.2. Notice that the marginal product of labor curve has been increasing all the way up to about 50 hours of labor. and is now beginning to decrease. This corresponds to the change in the slope of the production frontier in graph 11.1. Up to about 50 hours of labor, the production frontier is getting steeper and steeper, but at about 50 hours of labor, it starts becoming shallower. Since the marginal product of labor is the slope of the production frontier, as the slope becomes shallower, the marginal product of labor begins to decrease. Going from 60 to 70 workers, for instance, increases overall output by only 56, or about 5.6 per worker hour hired. And going from 70 to 80 workers increases overall output by only 44, or 4.4 per worker hour. At this point, the slope of the production frontier in graph 11.1b is beginning to become really shallow, and for the next 10 worker hours, going from 80 to 90, overall output only increases by 28, or 2.8 per worker hour. And going from 90 to 100 only increases output by 10, or about 1 unit per worker hour. When the production frontier becomes completely flat, completely horizontal, with no slope, which occurs at 100 labor hours in graph 11.1b, the marginal product of labor becomes zero. In other words, hiring additional hours of labor does not add to output at all, and therefore the additional output produced by one additional hour of labor is zero. Often students, when they first see a marginal product of labor graph, think that output is actually falling as we hire additional workers along the downward sloping or diminishing part of the marginal product of labor curve. That's clearly not true, because what marginal product of labor means is the increase in output that's produced by hiring one more hour of labor. As long as it's positive, as long as it lies above the horizontal axis, each additional worker is still adding to output, and output increases as we hire more workers. It's just increasing at a slower and slower rate as we move along the diminishing or downward sloping part of the marginal product of labor curve. It's only when the marginal product of labor becomes negative, that is, when it crosses the horizontal axis and goes below it, that hiring additional workers would actually decrease overall output. And that would require that the production frontier actually become downward sloping, because a downward sloping production frontier has a negative slope and thus a negative marginal product of labor. In the example here, we simply allowed the marginal product of labor to fall all the way to zero, but not to become negative, because we assumed that the production frontier becomes flat at 100 hours of labor.